Scene script. Have you ever wondered about the unseen, the elusive, the enigmatic dark matter that makes up a large part of our universe? Welcome to the realm of the unseen, a cosmic mystery that has baffled scientists for decades. This is the story of dark matter, a strange and elusive substance that, while invisible to our eyes and even our most powerful telescopes, is believed to make up a whopping 85% of the universe's mass. How do we know about something we cannot see, you ask? Well, it's a tale as fascinating as the universe itself. Dark matter does not absorb, reflect, or emit light, making it extremely difficult to spot. However, we know it's there because we can observe its gravitational effects on the things we can see. It's like knowing there's wind because we see trees swaying, even when we can't actually see the wind itself. Scientists first stumbled upon the concept of dark matter while studying the motion of galaxies. They noticed something strange. The galaxies were spinning far too fast for the amount of visible matter they contained. There had to be something else, something unseen, exerting its gravitational pull. Further evidence came from observing the cosmic microwave background radiation, the afterglow of the Big Bang. The variations in temperature and density in this radiation suggest the presence of a vast amount of unseen matter influencing its distribution. Moreover, dark matter plays a crucial role in the large-scale structure of the universe. It acts like a cosmic web, its gravitational pull drawing matter together into clusters, forming galaxies and galaxy clusters. Yet despite these observations, dark matter remains one of the greatest mysteries in science. We know it's there, we see its effects, but we don't know what it is. It's like a cosmic ghost, present yet intangible. Imagine then a universe filled with unseen matter, silently shaping the cosmos. The quest to unravel this mystery continues as we journey further into the unseen universe. What holds galaxies together? You might say gravity, but there's more to the story. Our universe is a cosmic ballet with galaxies pirouetting through the vast expanse of space. But have you ever wondered what keeps this dance from falling into chaos? What prevents the stars and galaxies from simply flying apart? The answer, my friends, is dark matter. Dark matter is an elusive, invisible substance that makes up about 25% of the universe. Yet despite its abundance, it doesn't interact with light or any form of electromagnetic radiation, making it incredibly difficult to detect. But we know it's there. We know it exists because of its gravitational effects on visible matter, on galaxies, on stars, and even on light itself. You see, the universe is full of matter that we can see, touch, and feel. We call this baryonic matter, and it includes everything from the smallest particles to the largest galaxies. But if you add up all the baryonic matter in the universe, there's simply not enough of it to create the gravitational forces necessary to hold galaxies together. That's where dark matter comes in. Dark matter provides the extra gravity that stops galaxies from flying apart. It's like an invisible hand that holds the universe together. Without dark matter, the universe as we know it would be very different. Stars would wander aimlessly through space, galaxies would disintegrate, and the beautiful cosmic dance we observe would descend into chaos. Yet, despite its crucial role, dark matter remains one of the greatest mysteries in modern physics. We can't see it, we can't touch it, and we can't detect it directly. But we know it's there, silently shaping the universe and holding it together. So when you gaze up at the night sky, remember that what you see is only a small part of the story. The stars, galaxies, and cosmic structures are all held in place by something we can't see, can't touch, and can hardly understand. Dark matter, in essence, is the invisible glue that holds the universe together. Why do scientists believe in something they can't see? It's a question that has puzzled many, but let's dive into the mystery of the missing mass, shall we? Picture a galaxy spinning in the vast expanse of the universe. Now, according to the laws of physics, the stars at the edges of these galaxies should move slower than those near the center because they're further from the bulk of the galaxy's mass. But here's the twist. They don't. The stars on the outer edges whiz around just as fast as those in the heart of the galaxy. This suggests that something unseen is adding to the gravitational pull. Then there's gravitational lensing. When light passes a massive object in space, it bends, much like the way light bends when it passes through a lens. We've observed this bending even when there doesn't appear to be enough visible mass to cause it. Again, this suggests the presence of an invisible mass. And finally, there's the cosmic microwave background. It's the afterglow of the Big Bang, visible in every direction we look. Tiny fluctuations in this background hint at the distribution of matter in the early universe. The patterns match up beautifully with our expectations if there's a large amount of unseen matter. These observations, among others, indicate that there's a lot more mass in the universe than we can account for with visible matter. We've looked for stars, gas, dust, black holes, everything we can think of, and there's still a huge amount of mass unaccounted for. So what could this invisible, undetectable stuff be? What's causing galaxies to spin as they do, light to bend in ways it shouldn't, and the cosmic microwave background to fluctuate just so? What's making up the majority of our universe's mass? This missing mass, dear listeners, is what we call dark matter. So you ask, what exactly is dark matter? Well, it's a fascinating question, one that has puzzled and intrigued scientists for decades. Let's start by clearing up a common misconception. Despite its name, dark matter is not dark in the way you might think. It doesn't absorb, reflect, or emit light, which makes it invisible to our eyes and our current instruments. It's dark because it eludes our understanding, lurking in the shadows of our knowledge. One might think that everything in the universe is made of atoms, those tiny particles consisting of protons, neutrons, and electrons. But dark matter is different. It doesn't consist of atoms or their usual constituents. Then what is it made of? That's the million-dollar question. Scientists believe that dark matter is composed of a new type of particle, one that we have yet to detect. These hypothetical particles are collectively referred to as WIMPs, which stands for weakly interacting massive particles. They're weakly interacting because they don't interact with ordinary matter or light in the way that we're familiar with. And they're massive because, well, they have mass, contributing to the overall gravitational pull of the universe. But remember, this is all theoretical. We have not yet directly detected a WIMP, but that doesn't mean scientists aren't trying. In fact, there's a global race to be the first to detect these elusive particles. Researchers are conducting experiments deep underground, away from cosmic rays and other forms of interference, in hopes of catching a WIMP in action. There's also another possibility. What if dark matter isn't made up of a new type of particle? Some scientists are considering alternative theories, such as modified gravity, which suggest that our understanding of gravity might need revising. Dark matter is a cosmic enigma, a mystery that continues to challenge our understanding of the universe. But one thing's for sure, it's out there, making up about 85% of the matter in the universe. This elusive particle, this ghostly presence, is the quest of many scientists today. Why should we care about dark matter, you might wonder? Well, let's draw an analogy. Imagine trying to complete a 1,000-piece puzzle with 1/3 of the pieces missing. You'd have an incomplete picture, wouldn't you? That's essentially the situation we're in with our understanding of the universe. Dark matter, this elusive, invisible entity, makes up about 27% of the universe. Without understanding it, we're missing a huge chunk of the cosmic puzzle. Just like discovering a new continent filled with unknown species of flora and fauna, unraveling the mysteries of dark matter could lead us to uncharted territories in science, with potential to overhaul our current understanding of physics. It's like holding a golden ticket to a revolution in scientific thought. We're on the precipice of potentially discovering new laws of nature that could redefine our understanding of the universe and our place within it. But the importance of understanding dark matter doesn't stop at scientific curiosity. The implications of this research could have far-reaching effects on our daily lives. In the past, theoretical physics has led to practical applications that have revolutionized our world. Think about how Einstein's theory of relativity paved the way for GPS technology, or how quantum mechanics gave birth to the technology that powers our computers and smartphones. Who knows what practical applications the study of dark matter could lead to in the future? Furthermore, understanding dark matter could provide insights into the fate of the universe. Will it continue to expand indefinitely? Will it eventually collapse back in on itself? The answers to these questions lie in our understanding of dark matter. So, while dark matter may seem like a distant, abstract concept, it's intricately connected to our understanding of the universe and the future of science. It's a reminder of how much we still have to learn and the thrilling potential of what we could discover. So next time you gaze at the night sky, remember the unseen universe, the dark matter, and the mysteries it holds.